Physics Part 118. The first law of thermodynamics. We have already met the law of conservation of energy. There it was stated in the following form: energy can neither be created nor be destroyed. It can only be transformed from one form to another. In this section we shall see how this conservation of law may be restated in relation to the terms like work, heat and internal energy. This will lead to an understanding of the first law of thermodynamics. I beg your pardon, please. Thermodynamics is the study of the processes involving the transfer of the heat. The thermodynamics is the study of the process involving the transfer of heat and the doing of work. In thermodynamics, we see the transfer of heat and doing of work. In thermodynamics, it is necessary to define the system under consideration. For example, the system may be an ideal gas in a cylinder fitted with a piston, or an electric heating coil in a container of liquid. In the chapter, we established the scientific meaning of work. Work is done when energy is transferred by mechanical means. We have just seen that the heat is a transfer of energy due to a difference in temperature. Work and heat both involve a transfer of energy, but by different means. We also know that the internal energy of a system is the total energy, kinetic and potential, of the various parts of the system. For a system consisting of an ideal gas, the internal energy is simply the total kinetic energy of all the atoms or molecules of the gas. For such a system, we would expect the internal energy to increase if heat were added to the gas or if work were done on it. In both cases, we are adding energy to the system. But the law of conservation of energy, this energy cannot just disappear. It must be transformed to another type of energy. It appears as an increase in the internal energy of the gas. That is the total kinetic energy of the molecule, which is increased, but if the total kinetic energy of the molecules increases, their average kinetic energy is also increased. Because the average kinetic energy is a measure of temperature, the addition of energy to the ideal gas shows up as an increase in its temperature. We can express this transformation of energy as an equation. The increase in internal energy of a system is equal to the sum of heat added to the system and work done on it. The increase in the internal energy is given by the symbol delta U. Heat added is represented by Q and work done on the system by W. The equation is then delta U is equal to Q plus W. Note that the sign convention which has been adopted, a positive value of Q, means that the heat has added to the system. A positive value of W means that the work is done on the system. A positive value for delta U means an increase in the internal energy. If the system does work, then we show this by writing work, W. If heat leaves the system, we show this by writing Q. Take care. There is an alternative sign convention that takes the work done by the system as a positive quantity. To avoid confusion, write down the sign convention you are using every time you quote the first law.